When an AB-620 question says one agent needs help from another capability, do not immediately jump to A2A. The exam is usually asking you to recognize the boundary. Is this a domain split inside one solution? Is it a separately published specialist agent? Is it a cross-platform protocol connection? Or is it not another agent at all, but a shared tool server or a connector call? The fastest way to stay out of trouble is to ask 4 questions. Who owns the capability? Does it publish with the parent? Does another platform or protocol boundary matter? And is the thing being called an agent that reasons, or a tool or service that performs an operation? Those clues decide the pattern. Imagine a Fabrikam support orchestrator. It handles order status, returns, and delivery issues. All 3 domains belong to the same support team, but each domain has different instructions, tools, and knowledge. Order status needs tracking and lookup tools. Returns needs policy checks, eligibility rules, and refund workflows. Delivery issues may need carrier escalation, exception handling, and customer updates. If you build all of that into one large agent, the descriptions blur and routing becomes harder to maintain. The better design is to keep one parent orchestrator and split the work into focused child agents that still live inside the same solution. A child agent lives inside the parent agent. You create and manage it from the parent canvas. It shares the same environment and solution. It is saved, tested, and published with the parent. That lifecycle clue matters. A child agent is not a separately published product owned by another team. It is a focused domain component of the same agent solution. It can have its own instructions, its own tools, and its own knowledge sources, but it does not introduce an independent release process. On the exam, words like same team, same solution, same lifecycle, organized tools, or split one broad agent into focused domains all point toward child agents. The parent still receives the user message. It evaluates the available routing options, topics, tools, and child agents. For a child agent, the description tells the parent what that child handles. If the request matches the description, the parent delegates the task. The child agent runs its own mini orchestration. It can decide which of its tools or knowledge sources to use, generate its response, and pass the result back. Then the parent continues the conversation. You can also invoke a child agent explicitly from a topic when you need deterministic control. The important boundary is this: the child runs its own logic, but it remains inside the same parent solution. Now change the scenario. The legal team owns a contract compliance agent. They publish it on their own schedule. Procurement wants to reuse that expertise, but procurement should not rebuild it or control its release. That is a connected agent. It is separately published, independently managed, and potentially reused by multiple orchestrators. It has its own identity, lifecycle, settings, transcripts, orchestration, tools, and knowledge. From the orchestrator's point of view, it is a callable specialist. Send it a task and get back a result. The exam clue is ownership. If a capability belongs to another team, should continue operating independently or should be reused by many solutions. Connected agent is the stronger answer than child agent. Connected agents are routed by descriptions. The orchestrator reads the user request and compares it to descriptions for topics, tools, child agents, and connected agents. That means descriptions are not friendly labels. They are routing controls. If 2 descriptions overlap, the orchestrator can call the wrong specialist. Suppose one agent says it reviews vendor contracts for compliance, and another says it evaluates vendor compliance and security posture. A question about compliance violations could match either one. The fix is usually not to recreate the connection. The fix is to refine the descriptions. Legal handles contract terms, data processing addenda, liability clauses, and procurement standards. Risk handles security posture, incident history, third-party risk ratings, and vulnerabilities. Clear boundaries create better routing. Once you know the capability is a connected agent, choose the connection option by where the specialist was built and how it communicates. Use an existing Copilot Studio agent when the separate agent is already published in the same Power Platform environment. Use a Microsoft Foundry agent when the specialist is built in Azure AI Foundry and has its own model or reasoning configuration. Use a Fabric data agent when a data team has built conversational analytics over OneLake data. Use a Microsoft 365 Agents SDK agent for SDK-built scenarios. Use an A2A protocol agent when the specialist is cross-platform and communicates through the open agent-to-agent standard. Do not pick A2A just because the word agent appears. Pick A2A when the protocol and platform boundary are part of the requirement. Connected agents can be coordinated in different ways. If the user arrives with open-ended needs, and the orchestrator should decide which specialist to call, use an orchestrator and sub-agent pattern. The user might ask about legal terms, risk ratings, or spend trends, and the orchestrator routes dynamically based on intent. If the process must run in a strict order, use a workflow-oriented pattern. A compliance process might call an intake agent, then a risk agent, then a legal review agent, then a human approval gate. In that case, the workflow engine defines the sequence. The AB-620 clue is variability. Open-ended routing points to orchestrator and subagent. Strict steps, dependencies, approvals, and audit trails point to workflow control. Connected agent design is not just routing. By default, conversation history can be passed to a connected agent, and that may or may not be appropriate. You need to decide whether the data flowing across the boundary is allowed under policy, data processing terms, and regulatory requirements. You need permission from the owning team, quality and security review, responsible AI review, and a plan for observability. Connected agents can generate their own transcripts separately from the orchestrator. When something goes wrong, you may need to correlate both conversations to reconstruct the interaction. If the connected agent can modify or delete records, approval controls become even more important. Connecting to someone else's specialist expands your trust boundary. Here is the exam trap. Do not count the number of agents. Read what kind of boundary the question describes. If the same team owns every domain and publishes everything together, prefer child agents. If another team owns a separately published specialist, prefer a connected agent. If the specialist is on another platform and the open agent-to-agent protocol is named or implied, choose A2A. If the requirement is a shared server-owned tool catalog that many agents use, choose MCP. If the requirement is just a direct service operation, data lookup or record update, use a connector or REST API tool. The right answer is not the fanciest integration. It is the pattern that matches ownership, lifecycle, platform, context sharing, and governance. Remember the grid. Connector or REST gets data and performs service operations. MCP calls shared server-owned tools and resources. Child agents split one owned Copilot Studio solution into focused domains without separate publishing. Connected agents delegate work to independently published specialists with their own lifecycle. A2A connects to cross-platform agents through an open protocol. For AB-620, read every scenario like an architect. Ask who owns the capability, who publishes it, whether it is reused independently, what context crosses the boundary, and whether you are calling a tool or delegating to reasoning. Those 5 questions will usually reveal the answer before the options try to distract you.